Hi everyone, welcome to my YouTube channel Advanced Learning Center. This is the disclaimer of my video. Today I am going to discuss about the analog question paper AE1 of third semester ETC department, Electronics and Telecommunication Engineering department. This question paper came in the year 2023 in State Council of Technical Examination, Technical Education Examination. That means all Assam Polytechnic examinations. So myself Tashir Ali Sheikh. Contents of this video of today's videos: AE Analog Electronics 1 question paper of 2023, solution of part A of AE question paper, solution of question number 1, fill in the blanks, solution of question number 2, write true or false, solution of question number 3, choose the correct answer. So this is the question paper that was come in the year 2023. This is end semester examinations. Subject code is ET305. Subject name is Analog Electronics 1. Total marks is 70. Duration is 3 hours. So there are two parts, part A and part B. Here part A 25 marks. There are 3 questions. Fill in the blanks, true or false, and choose the correct answer. So in part B, their first question is fill in the blanks. So in the later slide, we will be discuss about the one by one questions. So this is the question. Next is question number 2, write true or false. So here is also 10 marks. 10 question, 10 marks. So the one by one will be discussed later. Question number 3, choose the correct answer. Here are 5 questions, 5 marks. So total 25 marks, 10 plus 5, 25 marks is there in the first section, that is in section A. So this is the question. Now see question B, that means part B, 45 marks. Here answer any 5 questions, 3 marks of each, total 15. So for A, define insulator, conductor, semiconductor with example. For B, what are the acceptor and donor impurities? Give examples. Explain the behavior of PN junction under forward bias condition. 4D, what is the functions of the filter circuit? Draw the circuit diagram of a capacitor input filter. What is the basic purpose of biasing in BJT? What are the different biasing method used in BJT? Classify FET, draw the symbol of N-channel FET. Write the difference between the voltage and power amplifications. Question number A is define class A, class B and class C power amplifier. So these are question number 4, and next question is question number 5. Answer any 5. Here is 6 marks in each question, total 30. So first question is explain the formation of N-type and P-type semiconductor. Next question number 6B, what is PN junction diode? What is knee and breakdown voltage? What is the value of the knee voltage for semiconductor and germanium? Draw the BI characteristics, voltage current characteristics. BI means voltage, CI means current characteristics of a PN junction diode. Explain the working of a full wave bridge rectifier with necessary diagram. Explain the diode clipping circuit with waveforms. Explain the working of NPN transistors. Draw the symbol of NPN and PNP transistor. What is the difference between DMOSFET and enhancement MOSFET? Draw the output characteristics of N-channel DMOSFET and draw the symbol of N-channel and P-channel DMOSFET. 6G, draw the circuit diagram of complementary symmetric class B push-pull amplifier. Explain in operation. 5 each write short note on any two Zener diode, unipolar junction transistor, crossover distortion. So this is the question part A and part B. Next we will be discussing about the solution of question number 1. Fill in the blanks. So first question is the forbidden energy gap is very large in case of what? So in case of insulator, the energy gap is very high. So answer is the insulator. Process of adding impurities to a pure semiconductor is called doping. Okay. The voltage in minimum dash voltage is minimum reverse voltage at which PN junction breaks with sudden rise in reverse current. That means breakdown voltage is the minimum reverse voltage at which the PN junction breaks the sudden rise in reverse current. So answer is the breakdown voltage. Okay. Next is potential barrier of diode is increased if it is reverse bias. So potential barrier will be what happen of a diode is increased when it is in reverse bias. Then maximum efficiency of full AF rectifier is 81.20%. So now we will discuss how we got to 81.2% of efficiency of a full wave rectifier. So efficiency is the definition between it is the ratio between the DC power by AC power. So efficiency is the noted as in eta equal to PDC by PAC. That means DC power by AC power. It is the ratio between the DC power by AC power. So AC power is equals to, we can write down I RMS square equal into I R of F plus R of L. R is the reference resistance, R is the load resistance. And PDC equals to IDC square by RL. IDC means DC current square and RL means load resistance. So now see, IDC is equal to, we know that IDC values is equal to 2 Im by pi, where I is the maximum current of a circuit, and IRMS is again we can write down Im by root 2. So now substitute these all values in these equations, we will get IDC PDC equals to, we can write down this formula, PDC equal to, we can write down IDC by square by RL, and PAC equal to, we can write down I RMS square equal into I R of F plus R of L equals to, again this IDC equal to, we have substitute these values twice Im by pi whole square, this I square and this RL. Okay, again in place of P of AC we will be write RMS. In place of RMS it value is equal to Im by root 2 whole square, I RMS square was there, into this I R of F plus R of L. So now we will be cut this and this value both are square. Again this R of F will be many greater than R of L. So this also will be cancel. So in the later slide it will be, so where RF is many less than to RL. So in the later side we will be got here only 4 square means 2 square means 4 into this square, root over 2 whole square means 2. So 2 and 4 in upper 4, this also will be go in the upper, so it will be 8 in the upper, and in the lower only pi square. So this square is there, so here will be pi. So in percentage, so 8 by pi square equal into 100, it will be 81.4%. So that is the answer. Okay, so how we got, so this is the formula to find out the maximum efficiency of a full wave rectifier. This is the derivation. So next is collector region of BJT is moderately dropped. Okay, so if you see the table for collector region, emitter region, and base region, for the base region, doping concentration level is low. For emitter, it is heavily dropped, and for collector, it is moderate. And width is, in the case of base, it is narrow. Emitter, it is moderate. In collector, it is a wide of width. Okay, so next is the ideal value of stability factor in BJT is 1. So what is the formula for stability of the BJT is H equal to beta plus 1 divided by 1 minus D of IB by D of IC. So in case of ideal BJT, this value will be become, and this all value will be become 0. Okay, so if we substitute these values is equal to 0, so this will be what? Equal to 0 plus 1 divided by 1 minus 0, so it will be what? This value will be 1. So that's why this stability factor for ideal VGT is 1. The noise level in MOSFET is low. The current conductions is due to dash in N-channel JFET is one type of carrier. The current conduction is due to one type of carrier in N-channel MOSFET, and it may be either one type of maybe positive minority positive source, maybe negative source. Collector current follow only during the positive half cycle of the input signals in dash power amplifier. In class B amplifier, the collector current will flow only the positive half cycle. Okay, see here. So the different, this region is represent no area of no conductions. That means, so in class A, both the sides passes. That means in class A amplifier, current flow for the both of the input signal. That means be for positive as well as for the negative. In AV, positively is fully pass, negatively is negative signal is small part of the negative signal will be not pass. But in class B, only positive cycle is pass and negative cycle is not pass. So the answer is, that's why we have written in collector current only current flow only during the positive half cycle. So only the positive half cycle the current will be flow of the signal, and remaining part will be blocked. In class C, negatives positive half signals, a small amount of current will be flow, remaining will be block, as well as the negative parts also will be removed. So this is class B. Hope it will be clear. Next, question number 2, write true or false. The conductivity of a semiconductor is less than insulator, whether it is true or false. Conductivity of semiconductor is generally very higher than the insulator, so this is false. Conductivity is very high than semiconductor than insulator. So if you see the conductivity order, so conductor is higher than semiconductor and then insulator. Gallium is an example of pentavalent impurities. This is false statement because gallium is a trivalent impurities. Okay, this is gallium, indium, aluminiums, all are trivalent. Pentavalent is arsenic, antimony, and bismuth. So these are the pentavalent impurities. Diode act as a variable capacitor under changing reverse bias. So this statement is true because diode acts as a variable resistor under changing reverse bias. The ripple factor of half wave rectifier is 0.48. So this statement is false because it is 1.21. Okay, so ripple factor for half wave is 1.21. So ripple factor for half wave rectifier is gamma equals to 1.21. So next see how it is calculated. Just like the previous one, gamma equals to, it is written by I RMS square, I RMS by IDC whole square. So this is the formula, or we can write down B RMS by BDC whole square. RR cancel, so either it may be write down in voltage form, or it may be we can write down current form. So let's see the current form. I RMS square by IDC whole square. So I RMS already we have seen in our previous slide. So it is I RMS equal to, we can write down Im by 2, and IDC equals to, we can write down Im by pi. So here this Im and this Im will be cancelled. So here it will be in the upper side it will be pi, and in lower side it will be 2. So that means pi is pi by 2 whole square minus 1. So if you do the calculations, pi means 3.14 whole square by 2, 2 means 4, 2 square, so it will be 4. That means 3.14 whole square by 4 minus 1 equal to 1.41. So for the half wave rectifier the values is 1.21. So next is a positive clipper removes the negative half cycle of the input signal. So this statement is false because positive clipper removes positive half cycles of the input signal. So see here, this is the positive clipper circuit. So in the positive clipper circuit, one diode, one resistance is there. So what happens? This here is diode is reverse bias. So in the case of positive half cycle, the circuit does not conduct. So positive half cycle, positive half cycle will be not pass through the circuit because it will be open circuit. So here only in the case of negative cycle, this diode will be act as in forward bias, so the negative half cycle will be present in the output. So only negative signal will be present and positive will be removed. So positive will be removed, not negative. So that's why this statement is false. Next is clamper changes the peak value of a waveform. A clamper changes the peak value of the waveform. Yes, this statement is true. If you remember, the DC level will be changed. So that's why peak value will be changed. So this statement is true. If you see the positive clipper, here positive clamper circuit, here what happens, this is the input, so this is the output. So DC level will be what, it will be start from here 0, here 0, negative, positive. So here it is start from 0 and Vm is the 2 Vm DC level. So what happens, it will be start from Vm to 2 Vm into 0. So DC level, that means peak values will be changes. Again for the case of negative, the same thing is happening. It is start from 0 to minus Vm to minus 2 Vm. It is start from minus Vm. Okay, so DC level will be decrease here, and here DC level will be increase. Okay. So next, a PN transistors composed of two n-type semiconductor and one n-type semiconductor. So this statement is true. PNP transistor means here two p-type and one n-type. So this statement is true. Two p-type and one n-type. Voltage gain is very high in common collector configurations. So this statement is also false. So if you see the table for the common emitter, common base, common collector, here is the voltage gain. Voltage gain of the common emitter is high, common base is high, and common collector is about 1. So it is not very high, it is 1. So this statement is false. So other thing also given: current gain, power gain, phase shift, output resistance, input resistance. So if you remember this table, you can reply any answers of these three configuration, that is common collector, common base, common emitter. So next, come to the next one. A uni-junction transistor has one p-n junction. So this statement is also true because the basic structure of UGT is this. That means uni-junction transistor is there is one pair of p-n junctions. Okay, so that's why it is true. This statement is true. Frequency response of RC coupled amplifier is excellent in radio frequency range. So this statement is also true because if you see the characteristics graph or frequency response of the RC coupled amplifier, this is the lower frequency range, this is the higher frequency. So, in between the higher frequency and lower frequency range, so this frequency range is called nothing but it is the audio frequency range. So here is the maximum bandwidth is given. So maximum bandwidth is given means it is the excellent in audio frequency. So that's why this statement is true. Question number 3, choose the correct answer. Reverse saturation current in PN junction diode is due to minority charge carrier, majority charge carrier, both majority and minority charge carrier, and none of the above. So reverse saturation current in PN junction diode is due to minority charge carrier. The number of PN junction in a BJT is 1, 2, 3. So if you remember in the figure of BJT, so there will be 2 PN junctions. Okay, in unipolar junction 1 PN junction, here is 2 PN junctions. So see here, so here is here to here, here to 1 PN junction, again here to here another PN junction. So that's why answer is 2. So there are 2 PN junctions are there in BJT, bipolar junction transistor. So if alpha equal to 0.098 in a BJT, then beta is equals to 99, 98, 51, 49. So answer will be 49. So let's see how it is coming. We know the formula for beta equals to alpha by 1 minus alpha. So alpha values is 0.98, it is given, and 1 minus here will be point, so 0.98. So if we minus 1 from 0.098, below part will be 0.02. In upper side the same will be 0.0. So this point and this point will be cancelled. So here in the upper side it is 98, here it is 2. So 2 by 98, that is 4, 8, 9. So answer will be 49. So answer is this. A DMOSFET can be operated in depletion mode only, enhancement mode only, both depletion and enhancement mode, nothing of these. So a depletion MOSFET can operate in both depletion as well as the enhancement. See that I will the MOSFET operations, MOSFET modes of operation. There are two basic type of MOSFET. One is depletion MOSFET or DMOSFET, can operate in either depletion mode or enhancement mode. That means in both mode DMOSFET is operate. So here asking about DMOSFET, so both the mode it is operate. And enhancement mode can only operate only in enhancement mode only. Okay, so this is the DMOSFET, this is the EMOSFET. Okay, so this can be operated in both way, that means either in depletions as well as the enhancement, and this one is only enhancement mode. Transformer coupling is used for amplifications of power, current, voltage, none of this. So transfer coupling is used for if you notice in your practical, if you used any transformer, when you connect this transformer with the flagging point, In plugging points before the transformer, it is coming to 220 volt or 330 volt like that. But after the transforming point, if you measure through the multimeter, you will be get less current. So it is generally transformer coupling is used for amplification of current. Okay, so amplification of current. So thank you for watching this video. Please subscribe and like these videos and share with your friends, those who are studying diploma in electronics and telecommunication engineering in different polytechnics of Assam. And if you need the descriptions of your answer, please write on the comment box. I'll share. I'll try to come with the descriptions